Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode Problem 380, Insert, Delete, Get Random, Big O of 1. Let's read the question prompt. Implement the randomized set class. The randomized set will be initialized by calling randomized set. It will have a bool method called insert, which takes a value and inserts an item into the set if not present. Returns true if the item was present, false otherwise. Well, it'll have a bool remove method, which takes a value and removes the item val from the set if present, and returns true if the item was present and false otherwise. We'll also have a get random method, which returns an integer, which will return a random element from the current set of elements, and it's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. And we're given the constraint that we must implement the functions of the class such that each function works in average big O of 1 time complexity. So now that we've read the question prompt, let's think about how we might solve this question. Okay, we've read the question prompt. Now let's think about how we might solve this question. Well, what if we just try to use a standard set, right? That could be our first approach here, is just to use the regular set. Let's see what the problem with that would be. Well, we know that we can insert into a set in constant time. That's fine. We know that we can also remove from a set in constant time, so that property is fine. But the get random is where we're going to have the issue. And the reason for this is that we can't access elements by index in our set, right? So, if we got the size of the set and then we picked a random number between 0 and the size of that set, so that would be our index pick, we couldn't access that index because sets don't allow indexing, right? So sets wouldn't work because we can't use this get random. We would have to convert the set into a list and then access the element, but that would violate our big O of 1 time complexity because converting a set to a list will take big O of n time. So that's not an option. Well, what if we used a dictionary, right? We could use a dictionary here. Well, the dictionary would still give us the insertion in constant time. It would give us the removal in constant time. But again, we have the issue of get random. We can't get a random value in big O of 1 time for the same reason as the set. We would have to take the values, then, extracting the values out of the dictionary would be a big O of n operation. It would return us a list of the values, but then we would have to access, in order to access by index, we'd have to get those values, and that's going to be a big O of n operation. So we can't use a dictionary. What if we were to use just a standard list? Well, if we were to use a list, we could do the get random without issue, right? We could simply, just do like Python's random.choice on the list, and it would return to us in constant time, right? Because it's just going to pick an index from 0 to the length of the list and then just return our index. So we're allowed to get things by index in constant time. So get random would work. Remove, well, we could remove something from the list in constant time, but only if it's the last element in the array, because that means that we don't have to reshuffle the list, right? If we were to remove, say, the second element in our list, then we would have to reshuffle the remaining array, which would be a big O of n operation. So remove only works if it's at the end. What about inserting? Well, the same principle applies. We can insert to the end of the array, right? We can do dot append, and that would put it at the end, and that's going to be a constant time operation. But if we wanted to insert at any other index, then it would be a big O of n operation for the same reason that we couldn't do it for remove, because you have to reshuffle the array. So it seems like list sort of works under some conditions, but it's not really optimized for the insert, and it's not optimized for the remove. So what if instead of using just one data structure, we used two data structures? So we brought up the idea of using two data structures, but which ones are we going to use and how is it going to work? So what I'm proposing is that we use a combination of a dictionary and we use a list. So how is this going to work? Well, if we do this, whenever we get an insert, what we're going to do is we're going to insert it into the list first. right? So we're gonna have some elements. So say we have like 1, 2, 3, and then we were just asked to insert 4. So we're gonna insert that 4 into our list, and it's going to be, here at what index, right? It's gonna be now inserted at the 3rd index. So we now have it in our list, and then in our dictionary, what's gonna happen is we're gonna store as the key each value. So we're gonna say 4, which index does it occur at, right? So it occurs at index 3. So that way we can have our insertion happen in constant time, because remember, we're appending to the end of a list, which is, a big O of 1 operation. Inserting it into the dictionary is also going to be a big O of 1 operation. And, if we need to remove it, all we need to do is remove it from our dictionary, and then we have to do a little bit of magic with the list to actually remove it. So we've covered how we're going to do the insertions. It's quite simple. We just append to the end of our list here, and then we're going to add it to our dictionary by, putting the key and then saying which index we just inserted it at, which is always going to be the, length of our list -1, right? Because that's going to be the index of the last element that we just inserted, and it's always going to be that, so it's quite simple. But how do we actually do the get random? So let's think about this. The get random is quite simple, because we just literally call random.choice on this thing, or we can just generate a number between 0 and the length of our list here, non-inclusive, so it would be the range of 0 to so it'd be like 0, 1, 2, 3. So we could do within 0 and 3, just pick a number between there and then return the number. So that would take care of get random, and that could happen in big O of 1 time. But the removal part is difficult, because we can remove a key in a dictionary very easily by, just deleting the key, no problem. But how do we remove it from the list, right? We talked about how removals from the end of a list were big O of 1, but say we needed to remove this 2, that's not going to be a big O of 1 operation. How do we do this? Well, we can be clever, right? So let's recreate our dictionary here. So we'll have the value 1, which is going to occur at the 0th index. We have the value 2, which is going to be at the 1st index. We have the value 3, which is at index 2, and we have the value 4, which is going to be at index 3. So say we want to remove this 2 from the list, right? Removing it from the dictionary would be easy. All we have to do is delete the key, no problem. That's a big O of 1 operation. But like we said, doing it from the list is going to be big O of n. But how do we do that? Well, if you remember earlier, we said that removing from the end of the list is actually big O of 1. So if we could somehow move this to the end, then what we could do is we could just pop that key and it would be the last one. We don't really care about the order inside of our list here. We just use it to store values, so we can do get random in the end. So what I'm proposing we do is we figure out, okay, we need to delete 2. What index is it at? Well, we know it's at the 1st index. What is the last element in our array? It happens to be this 4, which is at the index 3. So what if we swap these 2 values? So now, what if we swap these 2? So now our list look like 1, 4, 3, 2. And then of course we'd have to update our map now, because now 2 is at index 3 and the 4 is at index 1. So we have to update our map here. And what we're going to do is we're going to say, okay, we've updated our map. Now 2 is at the end, which means that we can pop this in constant time. So popping it would be a big O of 1 operation, and then our list would look like this. And then at the end, all we would have to do is just wipe this key, and we have done everything in big O of 1 operations. So to summarize, what we want to do is anytime we want to remove something, what we need to do is swap it with whatever the last element in our list is, swap the 2, update the indices in our dictionary map here, pop the last element, or which I guess we do over here, we pop the element, and then we simply update, actually we've already updated the map here, so we're done. So that's how we're gonna do it. Let's go to the code editor and see how this might look like in code. Okay, we're back in the editor. Now let's write the code. Remember that we need to set up our data structures that we're going to use for this problem in the init function, which, if you recall, was a dictionary and a list. So let's set those up. We're going to say self.itemDict is going to be an empty dictionary, and we're going to say self.itemList is going to be an empty list. Cool. So let's handle the insert function. If you read here, what we want to do with the insert is only insert it if the item is not present. Otherwise, we just want to return false. So let's handle that. So we're going to say if val not in self.itemDictionary, that means that we need to insert it. So we're going to say self.itemList.append the value, and we're going to update our dictionary with that key and then the index that we just inserted it at, which is going to be the length of our item list minus 1. So we're going to say self.itemDictionary of our value is going to equal the length of self.itemList minus 1. And then we can return true. Return true. And otherwise, what we want to do is simply return false. Cool. So we've handled the insertion. Now let's do the delete. And like the insertion, we only want to remove a value if it's present in our array. Otherwise, we don't want to remove it. So we're going to say if val not in self.itemDict, then what we want to do is simply return false because there's nothing to remove. Otherwise, what we need to do is, if you recall, we need to pop the last element of our array because that's going to happen in constant time. And we need to make sure that the last element is the value that we want to be deleting here, this val. So we need to swap whatever the current last item is with wherever this value is. We'll swap them by index. And that way, our value that we want to get rid of is going to be at the last position in the array, and we can pop it in constant time. So let's figure out what the last element in our array is. So we'll say last element is going to be self.itemList minus 1, so the last element there. And we want the current index of the value that we're going to delete, because we need to use that to basically swap the two indice values. So we're going to say itemDict of val. Now we're going to perform the swap. So we're going to say self.itemList of the current index, and then the self.itemDictionary of the last element. We want to swap that with the last element and the current index, right? So we're basically just swapping the values of those two indices here. So that's what is happening in this line here. So now we can be sure that the item that we want to delete is going to be at the last index of our list. Now we can simply say self.itemList.pop, so that will get rid of that element. And now we need to also delete self.itemDict of our value. Now we can simply return true because we've deleted the element. And now the last thing that we need to do is simply do our Getrandom function. So we just need to return a random element from our item array. So we're just going to say return random.choice, and random.choice just takes a random element from an iterable. So we're going to pass it the list. We're going to say random.choice on item list. Cool. So that's going to be the code. And let's submit it. Let's double check that it works, and it does. Okay, cool. So let's briefly touch on the time and space complexity. So we know from our problem that everything needs to happen in big O of 1 time. So the time complexity is going to be big O of 1 because each one of these insert, remove, and get random is going to happen in constant time. What is the space complexity? Well, we know that we need to store elements in here, and it's going to be dependent on how many insertions we do. So this is going to be a big O of n operation, where n is the number of elements they ask us to insert into our randomized set here. So that is your time and space complexity for this problem. This is obviously the best that you can possibly do, and that is the solution for this question. I hope you enjoyed this video. If you did, please leave a like. Remember to comment and subscribe for more videos to help you prepare for your on-site interviews. Thanks, and happy coding.